Now, I need a captain. Have you owned a boat and been a captain of a boat?
No.
No. Would you like to be?
Sure.
Good. Okay, what's your name?
Roz.
Roz? Okay, Captain Roz. Okay. Captain Roz is the captain of this super tanker. Roz, captain, your job, if you will accept it, is to park it at the dock. Okay? To park it, you've got to take its momentum, which is big, and you've got to change that down to 0. Now, one way that you can do that is if you just turn off the engine and let the water in front of the boat push against the boat, it will bring the boat to a halt. Now, Captain, how long, according to your Mickey, before you want to park, do you think you should turn off that engine?
Quite a bit of time.
Quite a bit of time, an hour and a half. Now, have you known Captain Roz for quite some time?
I have known Captain
Would you, in all honesty, say that she's a patient captain?
I would not say she's
No, she is not. She is not. And she does not have to be, because she can stop that boat in just 23 seconds. How? Just ram it into the dock. 23 seconds and 3 city blocks later, it is stopped. Okay? It actually happened down in New Orleans, right there at the marketplace. So here's what the thing is. If you want to change momentum, you can do it with a small force if you're willing to wait a long time. Or you can do it quickly if you can supply a very large force. Now, this combination of force times time is what changes momentum. It's called the impulse. Okay? Now, I want you to look at something here. When we were talking about energy, it was force times distance that changed the energy, the Vec. But when it comes to momentum, the initial momentum is equal to the final momentum, except when it's not. And that's when I've got an impulse acting. That's how you change momentum, is with an impulse. Now, that formula of force times time only works when the force is uniform in time. If it's 50 newtons, 50 newtons, 50 newtons, 50 newtons, 50 newtons. But in most problems, that's not the way it is. If you hit a ball with a bat, the force acting on the ball is going to start at 0 when the ball first comes in contact with the bat. It's going to ramp up to some maximum value and then ramp back down. Now, you can calculate the impulse either by using calculus, which isn't our first choice, or you can just take the average force over that time and multiply by the time.